Okay, so there's only really a few angles coming into play here. So what I'm going to start with is looking at all the angles that have to be the same as the 41 degrees, 18 minutes, 32 seconds. So yell out some numbers. Which angles have to be the same as that?
2.
2 has to be the same. Good. Any others?
11.
11, and there's one more.
8.
8, good. So those angles all have to be 41 degrees, 18 minutes, 32 seconds. Now let's go with the 59 degrees, 38 minutes, 51 seconds. Are there any angles that have to be the same as that one?
10.
Angle 10, good. Now the rest of these are going to have to be calculated. So we're going to go up here and we're going to find angle 1. Its relationship with the 41, 18, 32 is that it's supplementary. So how do we find angle 1? There we go. Subtract from 180. So we have to borrow here because there's nothing here to borrow from. We go to all the way to the 180. That'll be 179. That would make this 60, which we have to borrow to make it 59, and this will be 60. Now we can subtract. 60 minus 32 is 28. That is not good. 28 seconds. 59 minus 18 is 41 minutes. And 179 minus 41 is 138 degrees. Any angles that have to be the same as that?
3.
3, good. So now our next move is to come down into this area down here. Let's look at angle 9. How would we find angle 9 there?
To add up the 59, 38, 51, and 41, 18, 32.
Perfect. These three angles have to add up to 180. So what I'm going to do is I will add up the 59, 38, 51, and the 41, 18, 32. So this is 83, which is more than 60. If I subtract 60, I'm left with 23 seconds, and I carry my 1 minute. That is 57 minutes and 100 degrees. And then we have to turn around and subtract that from 180 degrees. So again, we borrow. This will be 179. This will be 60. We'll borrow from it to make it 59. And this is 60. And we subtract. 60 minus 23 is 37. 59 minus 57 is 2. And 179 minus 100 is 79. So this is 79 degrees, 2 minutes, and 37 seconds. Any other angles that on here that have to be the same as angle 9?
12.
12 is 1. What else?
5. 5 and 7.
5 and 7. Good. Now we still need to find 4 and 6, but we don't have to calculate. We've actually already calculated them, even though we didn't necessarily realize we were calculating. What do this 4 and 6 have to be? Because we found angle 9 from subtracting from 180, and angle 9, which is equal to angle 5, is supplementary to angle 4, whatever we subtracted from 180 has to be what angle 4 is. It wouldn't have been that bad to go ahead and calculate it anyway, but we already have it. That is 100 degrees, 57 minutes, and 23 seconds. 4 and 6 are that angle. Which kind of leads us into one of our things for today. It looks like this. So I'm going to call these points A, B, C, and I'm going to put a C out here. And I'm going to label these angles. Let's call this 34 degrees. This one up here I'll call 92 degrees. I want to find this angle right here, angle CBD. That was not on purpose, but so how do I find angle CBD there? Well, I would start by finding this here, CBA. To find angle CBA, what do I have to do? What's my rule there? The three angles inside of a triangle have to add up to what?
80.
180 degrees. So to add up to 180, I'm going to take my 34 degrees and my 92, I'm going to add those together to get 126. I'm going to subtract those from 180. Gives me, what is that, 54 degrees? So this angle is 54 degrees. Now that I have that 54 degrees, how do I find angle CBD out here?
Subtract it from 180.
Subtract it from 180. 180 minus 54 is 126. We've seen that 126 before, though. Right here. Because of that relationship of adding up to 180 is a very common relationship. It allows us to find equality between a lot of different things. Here, because this 54 degrees has to combine with these two angles to add up to 180, because they're the interior angles of a triangle, and because they also, that 54 degrees, also has to combine with this angle to make 180, because those two add up to a straight line. That means that this angle, this exterior angle, is always equal to the sum of the other two interior angles of a triangle. So if I have a triangle that looks like this, and I tell you that this angle here is 98 degrees, and that this angle over here is 49 degrees. We know all of the other angles of that triangle. I'm just going to label this angle 1 and angle 2 here. I could find, if I want to find angle 2, looking down here, I could go the long way. I could find angle 1 because I know those two angles make a straight line. Then I could find angle 2 from that. Or I could just save myself some work, because we know from that previous example that these two angles, when I combine them together, have to add up to the exterior angle for the third angle. So I'm just going to take that 98 degrees for that exterior angle, and from it I'm going to subtract the 49 degrees for this other angle over here. 98 minus 49 is 49. So this angle here is also 49 degrees. Obviously, I didn't draw this very well. I didn't draw it as an equilateral triangle. But you guys get the picture. Now you might wonder, well, what if this had gone off the other direction? What if I was looking at this exterior angle instead of this one? Well, those rules that we looked at for intersecting lines, the 98 degrees and this new exterior angle are vertical angles. They have to be the same anyway. So in these triangles, or in these lines here, these two lines are parallel, and these two lines are parallel. If I give you this angle over here is 29 degrees, and I give you that this angle right here is 119 degrees, in your notes, find this angle here. Okay, so in this one, there's really only one calculation involved once you see the relationships. Because these two angles are parallel, this angle here must also be 190 degrees. Because these two lines are parallel, this angle here must also be 119 degrees. So now we have that exterior angle. We know that these two other non-adjacent interior angles have to add up to that. So we can just take the 119 and subtract this other interior angle of 29 degrees. Tells this angle here is actually 90 degrees. It's a right angle. Those angle relationships are extremely powerful as we go through everything we do. We've talked previously this semester about similar figures and similar triangles. Excuse me. We had triangles like this, and another triangle that might be a reduction or enlargement of that. if I told you that this side here, oh, what do I want to do here? Let's say this is 18 inches. Call this 9 inches. We'll call this one X. We'll call this one Y, and we'll call this here 10.5 inches. If I want to find those missing sides, X and Y, I first have to decide which sides are corresponding here. To do that, I use the angles. This angle is indicated with a single arc, and this has 2 arcs. Over here, this has a single arc, which means it's equivalent to this angle. This one has 2 arcs, which means it's equivalent to this angle. So this side, X and 10.5, those sides that are between those same 2 angles are corresponding sides. They're the same side from before the enlargement or after the enlargement or reduction. So then when I look, this is still the single arc, and this is not an unmarked angle. Over here is the single arc and the unmarked angle. That is the 9 inches, corresponds with the 18. And finally, this is double arc and unmarked angle for the 14 between them. Double arc and unmarked is the Y over here. So those are the corresponding sides set up by color. Now, to find the missing sides, we have to have one set of corresponding sides where we know both angles. And here we do have that. That is the 18 and the 9. So that is the first ratio in my proportion. I know that the 18 and the 9 compare to each other. Let's choose X to be the first missing side that we find. X is from the same figure as the 18, so it goes on top. Its corresponding side is the 10.5. Notice 10.5 is from the same figure as the 9-inch side. So I know I've stressed it several times, but when we're setting up these proportions, it is essential that we maintain those relationships in both directions. The 18 and the X are from the same triangle. The 9 and the 10.5 are from the same triangle. Going this way, the 18 and the 9 are corresponding sides. The X and the 10.5 are also corresponding sides. So now we can cross, multiply, and divide. 18 times 10.5 divided by 9 gives us 21. X would be 21 inches. And then we can do the same setup. Find our missing side Y. 18 relates to 9. Y is from the same triangle as the 9, so it's going to go on bottom. The corresponding side to the Y is the 14. And we cross, multiply, and divide. 9 times 14 divided by 18 gives us that Y is 28. Sorry, Y is 7, excuse me. Went the wrong way there. Y is 7 inches. Well, we've done this all before. I'm not going to go over a lot of it again. What I want to look at now is right triangles. If I have a right triangle, so I know that it has the right angle, that's the angle given. If I know this angle over here, let's say I know that that angle is 31 degrees. If I have another right triangle where this angle is 31 degrees, what can I say about those two triangles? Well, because we know that the right angle is 90 degrees in both triangles, hence the definition of a right angle, all we need to know is that one other angle. Once we know that this second angle is 31 degrees, we know that the third angle is also the same between them. Remember, up here we only needed 2 angles to be indicated, and it was given that the third angle was the same between the two triangles, because they always have to add up to 180 degrees. So we know by subtracting from 180 that third angle has to be 59 degrees in both triangles. If all of the angles are the same in between two triangles, they must be similar triangles. So we know that this side will correspond to this side. Both of those sides are the hypotenuse of their respective triangles. We know that this side will correspond to that side. It's the leg between the 90-degree angle and the 59-degree angle in both triangles. And finally, we know that this side and this side will correspond because it's the leg between the 90-degree angle and the 31-degree angle in both triangles. So the consequence is once I know it's a right triangle, or once I know that they're both a right triangle, if I know that one angle is the same, I drew this one rather poorly. Let's say I know that this here is 39 degrees. If I know that this one is also 39 degrees, that's all I need to know in order to know that those are similar triangles. So for right triangles, as long as one angle other than the right angle is the same, they will be similar triangles. That is the heart of right triangle trigonometry. We know that once we know that one of the angles in the right triangle is the same, the ratio of the other sides is the same for every right triangle that has that angle, that non-right angle in it. Every right triangle that has one 39-degree angle is going to have the exact same ratio from side to side to side. And that's what we use for our trig. For right now, in that packet, we're actually just a little bit ahead of pace. On page 295, 1 through 10, we'll finish off the stuff for page 295 on Monday. I'll let you guys have the last 20 minutes here to start on homework if you like. I will be on the network to give you